Hi friends, welcome to a tutorial video on NgRx. In this video, I'm going to explain about what is NgRx, why we need that, what are the fundamental components that make up NgRx, how we can start using it, and I'm going to explain all these using an example application. What is NgRx? NgRx is a state management library for Angular applications. It is inspired by Redux, which is a popular state management library used in JavaScript applications. NgRx follows the principles of a unidirectional data flow, making it easier to manage and synchronize the state of an Angular application. NgRx provides a set of building blocks that enable you to manage the state of your application in a predictable and scalable manner. These building blocks include actions, reducers, effects, and selectors. Let me show you the NgRx state management lifecycle. In NgRx, the application state is stored in a central store. Components can dispatch actions to update the state, and the state changes are handled by pure functions called reducers. Additionally, NgRx offers the ability to use side effects through effects, which allow for asynchronous operations such as making API calls. And selectors are functions that extract specific pieces of state from the overall application state. They provide a convenient way to retrieve and transform the state for use in different components of your application. Okay, what is the need for NgRx? NgRx offers developers a powerful toolkit to efficiently handle intricate application states, manage asynchronous operations, and maintain a consistent data flow throughout the application. It accomplishes this by enabling centralized state management and providing a structured approach that effectively scales as applications grow in complexity. NgRx has become widely adopted within the Angular community, fostering a thriving ecosystem of libraries, tools, and resources dedicated to supporting its usage. These are just theoretical explanations. I would like to explain the need for NgRx using an example. To understand the need for NgRx, it's essential to explore various methods of sharing data between components. To demonstrate this, let's consider a practical scenario, the add to cart use case. In this scenario, we have two pages that display different products and a header component that contains a cart. Whenever a product is added to the cart, the item count should increase. To illustrate different data sharing approaches, I have created multiple applications with the same component structure. Let's start with the first example. In this example, I utilize @input and @output decorators to emit an event from the fruits and vegetables components when the add to cart button is clicked. Subsequently, I capture this event in the app component where I add the item to the cart. Finally, I pass the updated cart data to the header component. And so we can see it is working. While the @input and @output decorators provide a way to share data between components in Angular, they do have some limitations and potential disadvantages. When using @input and @output, data can only be passed between parent and child components or between sibling components. If you need to share data between components that are not directly related in the component tree, it can become complex and error prone. As the application grows and more components need access to shared data, managing @input and @output relationships can become cumbersome. When using this concept, components become implicitly dependent on the structure and hierarchy of other components. This can make refactoring or reusing components challenging. @input and @output can also introduce performance overhead, especially when dealing with large or deeply nested component trees. Now let's move on to the next approach. In this example, I have used a service. Within this service, I have created the cart object. When the add to cart button is clicked, I directly update the cart within the service. Then in the app component, I retrieve the cart from the service and pass it to the header component. Since both components reference the same cart object, any modifications made to the cart within the service are immediately reflected throughout the application. This is very simple. While Angular services offer several benefits for data sharing and application logic, there are also some potential disadvantages to consider. As the application grows, the complexity of services can increase. Services can create a global state in your application as they are accessible and modifiable by any component that injects them. This can lead to potential conflicts and make it harder to track and manage data changes. It's important to design services carefully, follow best practices, and ensure proper encapsulation and separation of concerns. Otherwise, it will lead to some problems. Now let's proceed to the next approach. In this example, I have utilized the local storage. Upon application load, I create the cart object in the local storage. When the add to cart button is clicked, I retrieve the cart from the local storage, update it and save it back. In the app component, we can obtain the cart from the local storage and pass it to the header component. However, since this retrieval is typically done in the NgOnInit lifecycle hook, we need a mechanism to notify the app component when the cart is updated. To achieve this, we can employ a behavior subject. Essentially, we indirectly utilize a service by utilizing the behavior subject as a means of communication. The advantage of using local storage is that even if the application is refreshed, the state remains intact. However, it's important to note that local storage is not suitable for handling sensitive information since it is easily accessible. Additionally, any state that controls the application's behavior stored in local storage can be modified by users, potentially altering the intended functionality of the application. Considering all these, NgRx is often preferred for state management in Angular applications. Okay, let's use NgRx in our application. Before diving into the implementation, let's start with a simple use case to explain how NgRx can be utilized. I have modified this application slightly. When the plus button is clicked, the cart count should increase, and when the minus button is clicked, the cart count should decrease. First, we will integrate NgRx into our application. We can achieve this by running the schematic command ng-add@ngrx/store. Make sure you select the compatible version of NgRx. My Angular version is 14, and so let me use 14 here. Once the package is installed, you will notice that the app module and package.json files have been updated accordingly. Now we are ready to start utilizing NgRx in our application. First, we need to create an action. I can create this inside a folder. Actions represents the different events or user interactions that occur in our application. They are simple objects with a type property that describes the action being performed. Actions are dispatched to trigger state changes. In our application, we need to create two actions, add to cart and remove from cart. To define these actions, we can utilize the create action function from the store. Typically, we follow this format when creating an action. Alright, let's proceed with creating the reducer now. Reducers are pure functions that specify how the application state should change in response to dispatched actions. They take the current state and the dispatched action as input and return a new state. Let's go ahead and create the reducer using the create reducer function from the store. Before that, we need to declare the initial state. After declaring the initial state, we can utilize the on function to handle different actions and update the state accordingly. The actions can be imported from the actions file. Inside the root module, within the for root function, we can pass the created reducer. Now let me go to the add item component, and here let me inject the store. Inside the add to cart function, I will dispatch the add to cart action. Similarly, I will also dispatch the remove from cart action here. Once an action is dispatched, the reducer updates the state in response to that action. To access the updated state, we can use selectors. Selectors are utility functions that allow us to efficiently access and retrieve specific pieces of state from the centralized store. In the header component, I will inject the store, and then I can use the select method from the store to receive the updated state. This state will be an observable, so I will utilize the async pipe to resolve and display the data. Now when I increase or decrease the cart count, we can observe that the state is being updated accordingly. Okay, let me use the same application to demonstrate how we can pass additional data using props in the action. First, we will modify the action to include props. The props is going to be an object, and I am going to have a message property. Now when dispatching this action, I have the flexibility to pass the required data along with it. Inside the reducer, I can now receive and access this data, like this. Okay, Let's explore how we can enhance our original add to cart application using NgRx instead of the previous methods like at input, at output, service and local storage. I have already removed the service, local storage, etc. Now there is no communication between this add item component and header component, and so this will not work. And I have already installed NgRx store. Okay, first let's create an action using create action from NgRx store. I am going to pass a props of type object which is having an item property. Let me also create a reducer using create reducer from NgRx store. In which let me create an initial state which is having an empty cart. Now I will utilize the on function to handle the action. This function will receive the item from the props and add it to the cart, combining it with the existing items already present in the cart. Let me add this reducer to the store module. In the header component, we can utilize the select method from the store to access the state, which returns an observable. So I can either use the async pipe or I can subscribe to that to resolve that. Finally, we need to dispatch the action on clicking the add to cart button. Now we can see this is working again. In this application, we currently have a single state and we are managing it accordingly. However, as the application grows and we introduce more states, it's beneficial to create a common state file to handle all states in a centralized manner. By doing this, we can create a separate selector file to efficiently access the required states. This way, we can avoid scattered state management throughout the application. In the header component, instead of directly accessing the state, we can now use the appropriate selector to retrieve the desired state. This approach ensures that the header component is decoupled from the specific state implementation and remains focused on displaying the state data. Additionally, if we need to access a specific portion of the state, we can achieve this using the create selector function. In this case, I want to access the total quantity alone, which is what the header component uses. So I can implement it like this. Now in the header component, we can easily retrieve this total quantity and display it accordingly, like this. Okay, let's also explore the usage of effects in NgRx. Effects in NgRx are a powerful feature that allows you to handle side effects, such as asynchronous operations. For example, API calls. So far, I have hard-coded these fruits and vegetables data in the respective component itself. But now, I have made a slight modification to the code. Instead of hard-coding the data, I am now retrieving it from a service. To simulate an asynchronous flow, I intentionally added a delay of 5 seconds before returning the data in the ngOnInit method of the respective component. The problem with this approach is that every time I navigate to the component, the API call will be triggered, which is not ideal. To address this problem, a solution could involve moving the API calls to the ngOnInit of the app component. Additionally, a shared service can be introduced to store the data retrieved from the API. Subsequently, the respective components can access the shared service to retrieve the data without triggering unnecessary API calls. This approach allows for better control over data retrieval and prevents redundant API requests. However, a challenge with this approach arises when navigating to a component before the data is fetched. In such cases, the component's data will not be loaded until I navigate away and return. To overcome this limitation, I will need to implement a mechanism such as behavior subject to notify the respective component to pull the data from the service once it becomes available. By using NgRx, we can address all these challenges and achieve more robust and organized state management. Let's explore how we can do that. I have removed the shared service and made necessary changes to the code to remove the references. Now the fruits data is no longer loading. Okay, as the initial step, let me add 2 more states to our app state. Alright, let's proceed to create the actions. We will start by crafting an action responsible for loading the fruits data. Following that, we will establish a separate action to handle the successful completion of the loading process. Lastly, we will create an additional action to manage any potential errors that may occur during the loading procedure. Now we will proceed with the creation of the effects. We must first install the corresponding NgRx effects package. For my Angular version, I will proceed to install version 14 of NgRx effects, ensuring compatibility with the project. The effects will be implemented as a class decorated with the @injectable decorator. In this class, we can use the create effect function that can be used to manage the side effects in our application effectively. Let me also inject the actions from the NgRx effects. And let me check the type of the dispatched action using off-type function from NgRx effects and proceed with the API call. Let me also use some utility functions and operators from RxJS. And if the API call succeeds, we will dispatch the success action. And in case of an error, we will dispatch the error action. Alright, let's proceed to register this effect by utilizing the for root function provided by the effects module. This will enable us to set up and configure the effect to be used throughout the application. Now let's create a reducer that handles the action triggered when the load fruit success action is dispatched. In this reducer, we will specify the necessary steps to take when the action occurs, which involves updating the fruits data in the current state. We are almost done, and just one final step remains. We need to create a selector to access our state from the store, making it accessible to the components and other parts of the application. Now let me go to the app component and let me dispatch the load fruits action. This action will trigger the effects, and upon a successful API call, the load fruit success action will be dispatched. Subsequently, our reducer will react to the action and update the state with the retrieved data. This way, the fruits data will be available and accessible within the application. Alright, now I will go to the fruits component where I will utilize the select function from the store to retrieve the fruits data. This function will allow me to access the fruits data that has been stored in the state and use it within the fruits component as needed. Let's preview once. We could see this error because as we have added more states, this cart reducer is expecting the same. Let's add. Now it is okay. But still our fruits data is not showing up. That is because we have created fruits reducer, but we have not registered that in our root module. Let's do that. Now we can see the fruits data. Let's proceed with a similar setup for fetching vegetables data. We will follow the same steps we used for fruits data, creating actions, effects, a reducer, and a selector to handle the API call and manage the state for vegetables data. This will ensure consistency and a well-organized approach for handling both fruits and vegetables data in our application. Now we can observe that Upon the initial load, after a few seconds, the fruits data is successfully loaded. When we navigate to the vegetables page, we can see the vegetables data as well. Subsequently, if we return to the fruits page, the API call is not triggered again, ensuring efficiency. Additionally, during this time, we have the option to add products to the cart, enhancing the user experience and interactivity of the application. So this is how we can use NgRx in our applications to design a robust and organized architecture using actions, reducers, effects, and selectors. By leveraging NgRx, we achieved smooth data loading and storage, making API calls only when necessary and avoiding redundant requests. Our application became more responsive, resulting in a seamless user experience. I hope this tutorial has provided you with valuable insights into NgRx and its potential to enhance Angular applications. As you continue to dive deeper into NgRx, you will discover even more ways to optimize and scale your projects. See you in my next video. Thank you. Bye.